Hey everyone, welcome back to my channel. I'm Rishikesh. In this video, we are going to walk through a complete machine learning project that predicts traffic accidents based on real world conditions like weather, road type, time of day, and more. We'll go from loading and cleaning the data through data analysis, all the way to training and evaluating machine learning models, including random forest and logistic regression. Let's dive in. Load and clean the dataset. Let's begin by loading our dataset, which contains records of traffic accidents along with details like weather, time of day, road conditions, and more. We're using Pandas to load the CSV file. If you want, you can use other files. And then we immediately drop any row with missing values to keep our dataset clean and consistent. Going to the next cell, correlation heat map. We generate a correlation heat map for all numerical features. It helps us to how strongly and different variables relate to one another. In this, with high correlation might be redundant, and those highly correlated with the target could be powerful predictors. Going to the next cell, weather versus accident rate. Here, now let's look at how weather impacts accident rates. This bar plot shows the average accident rate for each weather conditions. As you can see, certain conditions like fog or rain may contribute to higher accident risks. And going to the next cell, road type versus accident rate. We're comparing accident rate across different road types, intersections, roundabouts, or highways. Each environment poses a different level of risk. This helps us identify high-risk road setups. And going to the next cell, time of day versus accident rate. Let's examine how time of the day impacts accidents. This makes sense. You might accept more accidents during rush hour or late at night due to fatigue or poor visibility. Accident severity versus accident rate. This chart shows how accident rates differ based on severity levels. It's useful for understanding and distribution of serious versus minor accidents, and also flags whether our dataset might be imbalanced. And going to the seventh cell, road condition versus accident rate. Now we look at the influence of the road conditions such as dry, wet, or under construction on accident likelihood. Poor or slippery conditions often shows higher rates of incidents. Going to the eighth cell, vehicle type versus accident rate. Different types of vehicles can behave very differently on the roads. This helps us analyze which type are more prone to accidents, whether it's motorcycles, cars, trucks, or buses. And going to the ninth cell, road light condition versus accident rate. Finally, we visualize how lightning conditions on the road affect accident rates. Not surprisingly, accident tends to be more frequent in darker conditions without proper street light. And a tenth cell, encoding categorical features. Before training any model, we need to convert our text-based categorical features into numbers. We loop through all object type columns and apply a label encoding, and this turns categories into integers, making the data usable for machine learning. Going to the 11th, features and target plus train, test, split. Naresh, we now separate our data set into features and target. Then we split it into training and testing sets using 80% of the data to train the model and 20% to test its performance on unseen data. 12th cell, train random forest classifier. Let's train our first model, a random forest classifier. It's built multiple decision trees, combines their predictions for better accuracy. We then use it to predict on our test data. Going to the 13th cell, training logistic regression. We train a logistic model. It's simple and interpretable and serves as a great baseline. We increase the max iterations to ensure convergence and then predict just like we did with random forest. Going to the 14th cell, classification report for both models. We evaluate both models using slick learn classification report. It gives us metrics to precise recall, F1 score, and support, helping us understand how well the model predicts both accidents and non-accident cases. Going to the 15th cell, custom evaluation function plus confusion matrix. So to make comparison easier, we create a custom evaluation function. It prints the accuracy, precision, recall, and F1 score, and also visualize and the confusion matrix. So we can clearly see how many predictions were correct versus incorrect. So going to 16th cell feature important plot, random forest. Using the trained data set, random forest, we extract features importance scores. This shows us features had the most influence on the model's predictions. Use as insights into what matters. When it comes to accident likelihood, um, this trained random forest, we extract feature importance scores works. Going to the 17th cell, ROC curve for random forest. We plot the ROC curve for our random forest model. This shows how well the model separates the two classes across different thresholds. The area under the curve summarizes overall performances. The closer to one, the better. So, and here you can see the finally we plot the ROC curve like this, and you can see the plots. And that wraps up our traffic accident prediction project from data cleaning and EDA to training models and evaluating performances. Random Forest gave a strong result with high precision and recall. Be sure to check the description for the full code and stay tuned for part 2, where we'll fine tune and model or deploy it with a simple dashboard. Okay, thanks for watching.